Hi class, my name is Tessa Hunter and the mathematician I chose for this assignment was Rene Descartes. Here is a picture of him. Rene Descartes was a renowned scientist, philosopher, and most importantly a mathematician, and we'll be going over his successes in that field during this presentation. To start off in his early life, he was born in La Haye in Touraine, France, which is now known as Descartes, France, in March 31st of 1596. I believe they named Descartes' France after him after he died. And at the age of 11 years old, he went to the Jesuit College of La Fèche, and there he studied the classics like mathematics, physiology, and science. And during that time, I believe he studied for about 5 or 6 years at grammar school, and that included Latin and Greek grammar. He also studied classical poets like Cicero, and he followed that by 3 years of physiology curriculum. And I found all that information on the Stanford Encyclopedia of Physiology about Rene Descartes' life in section 1.1. And after all that, he still wanted to have more for his education, so he went to the University of Poitiers in France. And there he just studied for a year, but he got a law degree, which he received that in 1616. Rene Descartes was regarded as the father of modern physiology, and he was a key figure in the development of mathematics and scientific thought. And although throughout his life he was regarded as that, he expressed doubts about the value of his education, and he repeatedly said how he may have gained nothing from quote-unquote his attempts to be educated. And although he had his sentiments about that, he still continued to pursue his knowledge throughout his life, and he ended up publishing ideas on mathematics and science about a lot later in his life, till about 1637. And Rene Descartes was a very revolutionary figure in this time. It was also the scientific revolution, which was a transformative period of time as well. The timeline of the scientific revolution was kind of hard to date, and historians definitely argued about that, but they kind of had a rough time frame for about 1500 to 1700. In one of my sources by Cartwright, it was said that actually Cartwright was the author, and the article was the World History Encyclopedia, and it was talking about the scientific revolution. And that quote said that it was not a single dramatic event, but rather a long and gradual series of discoveries and changes in attitudes of knowledge. I note that I feel like Rene Descartes' story had a very similar time frame or idea about like the scientific revolution, because it took him a long time to finally regard his ideas as good, and took him a long time to publish his ideas as well. Throughout the scientific revolution, many advancements were made in biology, mathematics, chemistry, and just science in general, and it helped many people understand the natural world along with the scientific one as well. And like I said earlier, during this period, Rene Descartes had a significant impact on math, and he made revolutionary ideas that are still used in the 21st century. His work laid many ideas and laid the foundation for modern physiology and in analytic geometry. One method that is still used to this day, like I said, is the Cartesian coordinate system, and that helps us do many things. In one of our textbooks named Developmental Math, it writes of that the Cartesian coordinate system, or also known as the coordinate plane, consists of a horizontal axis, x-axis, and a vertical y-axis, and they intersect at the origin of a 0, 0. These are divided into a plane into 4 quadrants, which you can see here, and they're labeled from 1 to 4, and they go in a counterclockwise direction, so it goes 1, 2, 3, and 4. The points are located using ordered pairs, which is x, y, and that is where the first value indicates the horizontal position, and the second is the vertical. The origin has both coordinates that are equal to 0. The Cartesian coordinate system is essential in many different types of math problems, and in the book Contemporary Mathematics, there are many ways this method is used, and it allows for the question to be answered in a quicker fashion. And in Chapter 10, Lesson 1, the Cartesian coordinate system is used when graphing planes. Here is the example here from Figure 10.17. Figure 10.17 consists of 3 points, which is S, R, and T. T and R are collinear, so they're together, and they form a line segment. Point S is not in the line segment, as you can see. And those all represent a plane. Find the first number of the ordered pair in the horizontal or Cartesian plane. The first number in the ordered pair is the horizontal move, and then the second number is the vertical move. So like X is the horizontal, Y is vertical. In our graph, we can see that point R is located at 4, 2, so you go 4, 2. And then point S is located at -3, 4, so you go -3 is the first number, and then 4. And then lastly, point T is located at -1, 1, so we go -1, 1. From that, we can identify that the line segment is RT. And all of that is in contemporary mathematics, found in Figure 10.7. Believe the Cartesian coordinate system is trying to find just these numbers right here. Obviously you know this one, but we have to find the line segment and the plane. Rene Descartes didn't live too long of a life. He died in Stockholm, Sweden on February 11th at 1650, and he was 54 years old. But even in that short time frame, he paved the way for future developments in calculus, physics, and modern science, and it helped the world of mathematics as well. His legacy, it remains as an essential way to understand math today, and we all should thank him because it helps with all of the things we learned.